Hello, my name is Gabriel, and today's topic on taking mathematical induction. So what is mathematical induction? Mathematical induction is a mathematical technique for proving that a result is true for any value of n in an expression. The result must be true for any value of n, which is n is equals to k, and it must also be true for the next value of n, which is n is equals to k plus 1. So let me explain further by using a question. So what is given now is 1 plus 2 plus 3 plus 4 into infinity plus n is equals to n into bracket n plus 1 over 2. So we have to prove that n into bracket n plus 1 over 2 works for all variables in the expression. Solution. Step 1. We prove that the result is true for the particular value of n equals to 1 and n equals to 2. That's step 1. So even if we add 1 to n into bracket n plus 1 over 2, so we say 1 is equals to n is equals to 1 into bracket 1 plus 1 divided by 2. We are still going to get 1. 1 plus 1, 2. 2 times 1, 2 divided by 2 is 1. So even if we try this method too, 1 plus 2 is equals to 3, because you know it's a sequence. We're going to be summing it up. So if we are adding 2, we're going to sum 1 plus 2, which is equals to 3. So if we sum it up, we get 3. Then if we add 2, so it will be 2 into bracket 2 plus 1 equals to n. 2 into bracket 2 plus 1 divided by 2, which is equals to, it will still give you 3. That's 6 divided by 2, which is 3. So step 2, I have confirmed step 1. So it is true if n is equals to 1 and n is equals to 2. So step 2, we prove that the result is true for the particular value n is equals to k. So even if we add 1 plus 2 plus 3 plus 4 ... plus k is into bracket k plus 1 divided by 2, it's still the same thing. So we are very sure that even if n is equals to k, it is still true. So we check step 3. So step 3 now, we prove that the result is true for the particular value n is equals to k plus 1. So even if we add one more value to n, we must still be sure that it is true. We must prove that it is true for that value. So we must remember a formula they usually use for especially sequence. Summation k plus 1 is equals to summation k plus k plus 1. Summation k plus 1. Summation is representing n into bracket n plus 1 divided by 2. That's what the summation is representing. So because there's a k plus 1, summation k plus 1, we're going to replace n with k plus 1. Anywhere we see n, we put k plus 1, which is k plus 1 into bracket multiplied by k plus 1 plus 1 divided by 2. So the next one is equal to summation k. Summation k, summation is still n to bracket n plus 1 divided by 2. So we just replace it with k, which is k into bracket k plus 1 divided by 2 plus k plus 1. K plus 1 is representing n That's what k plus 1 is representing. K plus 1 is representing n. So we replace n with k plus 1 and get k plus 1. So if we solve this, on both sides we are supposed to have k squared plus 3k plus 2 divided by 2. On the other side too, we have the same thing, k squared plus 3k plus 2 divided by 2. So therefore the result is true for any value of n. It is also true for the next value of n. We have proven it. So let me take another question. Summation into bracket 2i minus 1 close bracket, and we have been told that I is equals to 1. I is equals to 1 equals to n squared. So to solve this, we are going to arrange it in a sequence the way it should be, and we'll say we put 1, 2, 3 like that. Okay, and that's 2 times 1 minus 1 plus 2 times 2 minus 1 plus 2 times 3 minus 1 plus 2 times 4 minus 1 plus like that. Then we put what we will use to calculate for the last number in the sequence equals to n squared. So if we solve it, we get 2 times 1 minus 1, that's 1. 2 times 2 minus 1, that is 3. 2 times 3 is 6 minus 1, 5 plus 7 dash plus 2i minus 1 equals to n squared. So we have gotten back the way our question should look like. Step 1, according to what I've said earlier, we are going to add 1 and 2 for the values of n to prove whether it will still work for any of the values. So 1 is equals to, we are using n squared. 1 is equals to 1 squared, which is equals to 1. And remember, we're going to add 1 plus 3 for the second summation, and that is 4. 1 plus 3 is equals to 4. So for the second summation, we'll put 2. That's 2 squared is equals to 4. Now step 2, let n be equals to k. If n is equals to k, it is going to be true. So step 3, now we prove that n is also equal to k plus 1. If n is equal to k, we are going to prove that n is also equal to k plus 1. So according to the formula I mentioned earlier, S summation k plus 1 is equal to summation k plus 1. So the summation there is representing n squared. We put k plus 1 as n, so it will be k plus 1 squared, which is equal to summation k. Summation is n squared, yes. So anywhere we see n, we press k, and we get k squared plus k plus 1, as I've said earlier, that 2i minus 1. So I will be k plus 1. I is also equal to n. So I and n is having the same value. So if we solve it, we should get k squared plus 2k plus 1, which is equal to k squared plus 2k plus 1. So we're going to solve a different question now. It's slightly different from the other ones we have been solving. Still deals with mathematical induction. Okay. Number 1, prove that 6 raised to the power n plus 4 is a multiple of 5. N is a positive integer. All values of n is a positive integer. Okay. Note, in this case, whatever value we add in as n in the expression must be divisible by 5. So whatever value we add in as n, and the expression must be divisible by 5. So let me explain this further. Step 1 now, let's prove that the result is true for n equals to 1 and n equals to 2. So 6 raised to the power 1 plus 4 is equals to 10. So if we divide it by 5, we get 2. So it's divisible if we add 1. 6 raised to the power 2 is 36 plus 4, 40. Divided by 5 is equals to 8. So even if we add 2 as n, is divisible by 5. So step 2, we have confirmed step 1 by proving it. So step 2, let n be equals to k. So we're going to make n k now. So we'll say 6 raised to the power k plus 4 divided by 5 is equals to q. That q is representing the answer if we divide it by 5. We are going to make 6 raised to the power k the subject of the formula, and it's not a formula. 6 raised to the power k the subject equals to 5q minus 4. 6 raised to the power k is equals to 5q minus 4. Okay, step 3 now, prove that the result is true when n is equals to k plus 1. Yes, even if n is equals to k plus 1, let's prove whether it will still be true. 6 raised to the power k plus 1. Remember, we are changing n to k plus 1. 6 raised to the power k plus 1 plus 4 is the same thing as saying, according to indices, is the same thing as saying 6 raised to the power k times 6 plus 4. So we replace 6k to what we got earlier, 5q minus 4. So 6 raised to the power k is the same thing as 5q minus 4. So 5k minus 4 times 6 plus 4. At the end, we are going to get 30q minus 20. If we factorize it, 5 is the factor. Yes, 5 is the factor of the both 30q minus 20. So it will be 5 into 6q minus 4. We are going to say, therefore, 5 can be divided by 6 raised to the power n plus 4, no matter what n is. So I believe by this you should understand. Please like and share this video, and also subscribe to this channel. If you have any questions, you can ask in the WhatsApp group for further explanations.